It's Dr. J. 3.5 today. We're finishing the chapter. The full title is Solving Equations Involving Integers, but I couldn't fit that on the screen, so I'm just calling this Equations Involving Integers. Obviously, we are going to solve. Typically, that's what we would do with an equation. The only difference between this section and the previous sections with equations is now we can involve negative numbers, and we're also going to learn a new principle or property called the division or the multiplication property. Let's go ahead and just start off with some relatively simple equations. Something like this. For my first few examples, we'll just have a single variable x. As we get more into it, we'll have x's in various places and things like that. So remember, the idea of solving an equation basically comes from isolating the variable. So we would like the variable to be alone. It doesn't really matter what side it's on. I typically just go with whatever seems easier. Sometimes I'll do it the hard way, and then when I'm done, I'll go, oh God, I could have done it a different way, but you might discover that on your own. First thing you want to do, step number one, is combine any like terms that you have. So notice on this side, there's no like terms. This has a variable. This does not have a variable. So that side will stay the same. But the right-hand side, you're going to combine the like terms. That's going to be -5. -9 plus 4. Okay. I'm going to be doing the addition and subtraction from the previous sections much quicker than I was in the original lessons. Otherwise, we'll never get through this. Okay, now to get the variable isolated, you're going to subtract 16. Or I like to actually say add -16. I mean, yeah, you are subtracting, but remember from the previous lessons, subtracting is the same as adding a negative. So it's -5 plus -16. If it helps you to put a little invisible plus sign here, you certainly can. I typically don't. I just think in my head I'm adding, so that would be -21. Okay. I will show you how to check, but again, I've said this before, if I check every answer in this lesson, this is going to be a 2.5-hour lesson. So I'm just going to show you generally how you check, and then you see if it's right. On the homework in the lab, you don't need to check your own answers, but on a test or a quiz, I highly recommend doing this. So you're going to plug in your candidate. That's what we call it before you've checked. And then you're just going to verify that the two sides both come out to be the same value. And they do. -21 and 16 is -5, and -9 plus 4 is also -5. Check. Now, I said this before, and I'll probably say it again. When you check, be very careful that you don't put -5 as your answer. Sometimes your brain will run away from itself, and you'll totally forget that the answer was actually -21. So what you're checking is that this is -21. This is what's called the check value. This is called the solution. -5 is just the check value. It means that the two sides of the equation check. They equate to each other. They're the same value. All right. I'm not going to do that unless it becomes absolutely necessary. All right. We're just going to trust that our answer is correct. Although I'm setting a really bad precedent. Time is of the essence here. All right, let's do a few more of these. How about something like the same old story, isn't it? Come on back. There we go. All right, so this time the variable's on the right-hand side. Now you could go through all the trouble of trying to move the variable over to the left-hand side, but I'm really more of the philosophy, you know, life gives you lemons, you know, make lemonade. So if life gives you a variable on the right-hand side, well, just deal with it. Yeah, it's fine. You first want to combine any like terms if possible. So 4 minus 7 is negative 3. And then we're going to add 8 to both sides. Now, negative 3 and positive 8, when you add them, you get positive 5. I bet you we could squeeze another one in here. Okay, so now we have variables. So these are like terms, variables on the left, constants on the right. So combine all your like terms first. So 2x minus 1x is just x. If you like, you can actually put the invisible 1 here so you can really see that this is 2x's minus 1x gives you 1x, right? This is what we call the invisible coefficient. So if you don't see a coefficient, it's an invisible 1. And then 3 minus 5 is negative 2. You are done at this point. You don't need to put the invisible 1. I typically omit it. So the solution is x equals negative 2. That one kind of solved itself. All right, so that pretty much does it for the basic, I'll call those the basic integer equations. In order to solve the more complicated ones, the equations that might have a coefficient other than 1, we're going to need a new property. So we call this the division property of equality. The division property says that if A is equal to B, then A divided by C is equal to B divided by C. In other words, if you divide both sides by the same number or the same value, then the equation is preserved, or the equality is preserved. And again, going back to the very beginning of I guess not the beginning of the semester when we were solving equations, I believe it was in chapter 1, we talked about preserving inequality, keeping the balance. Yeah, they're balanced like a scale. Yeah, so the scale stays balanced if you divide both sides. We assume that C is not 0. You're not dividing by 0. So you can divide by any number, divide both sides by any number except 0. If you if you divide by 0, don't worry, you're not going to divide by 0. But just to put that out there that you can't do that. That would definitely not preserve the equality. So we can use this property to solve equations that have a coefficient. Typically, C stands for coefficient. So that's what you're dividing by is C. Coefficient's a fancy way of saying the number to the left or in front of the variable. So let's see an example. Something like this. So this is C, coefficient. Now, I'm not going to actually write the A and the B. I know I did that once back in chapter 1, and at the time I said I'll do it at the beginning and then I'll stop doing it. A and B are just quantifiers for the sides of the equation. So A is the left-hand side of the equation and B is the right-hand side of the equation. So this literally says A is equal to B. That's what we mean here. I'm not actually going to use the letters A and B. C is the coefficient that you're trying to remove to isolate the x. So you're going to divide both sides by C. So now this is A over C equals B over C. Now 2 divided by 2 becomes 1. That's why we call it the division property. So 2 divided by 2 is 1. So it's 1x. Negative 10 divided by 2 is negative 5. And we typically omit the 1. Most of the time, we just jump right to here. We say 2 divided by 2 is 1x, and we just don't bother writing the 1. Okay. So that is the division property. Should we try another one? Sure. I don't hear any objections. All right. Couple things that I want to point out. The coefficient is what you divide by. Do not change the sign. So you don't want to divide by positive 3. Do not do that. All right. If the coefficient is negative, then you want to divide by a negative. So this is not an opposite principle. This is an exact principle. I call it fighting fire with fire. Yeah. So if you have a negative, how do you get rid of it? You get rid of it with a negative. If you have a positive, how do you get rid of it? You get rid of it with a positive. Because we're not using the opposite. We're using the division principle. Our goal is to make this 1. So you get negative 3 divided by negative 3 is 1. 1x. And then over here, negative divided by a negative is 6, so you just get x is equal to 6. At some point, I'll start skipping this step here. All right. Also, don't divide by the variable. That's a big one I get a lot where people do this. Oh, no, that screws everything all up. Because then your variable will cross off as well and become 1. You don't want to do that. So you're only dividing by the coefficient. That's it. You're just trying to, sometimes we call it stripping the variable. Yeah, so the variable has this coefficient attached to it, and you're stripping it off and getting the variable isolated. Right? You're sort of cleaning off the variable, getting rid of that extra coefficient. Okay, we're ready to dive into the deep end now. Now that we have the principles, example 6. All right, we got 2x minus 5x equals 21. There's nothing to do on the right side. It's already simplified. So the left-hand side, you can combine the like terms. It's negative 3 again, coincidence. 2x minus 5x. Be careful with the sign. It's negative 3x. Okay, then you're going to divide by the coefficient. That becomes 1. Positive 21 divided by negative 3 is negative 7. Let's try to squeeze another one in here. All right, this time our variable is on the right-hand side. Combine those together. 2x plus 3x is 5x. The coefficient is now 5, so divide both sides by 5. Negative 60 divided by 5 is negative 12. It looks backwards. Typically, you can just solve it backwards and then write your answer like this. That's the way you'll type it into the computer. The computer always reads x equals going from left to right. Even if you solve it backwards, it doesn't change the truth. The truth is that x is equal to negative 12. Okay. X minus 2x is equal to 9 minus 6. So x minus 2x is negative x. Yeah. Or if you prefer, I know I do in this particular case, I like to actually write negative 1x. This is a case where I personally like to see the 1. And you'll see why in a second. And then over here, 9 minus 6, that's just ordinary subtraction, so that's 3. And the reason why I like to see the 1 is because then it tells me the coefficient is negative 1, and now I'm going to divide both sides by negative 1, and my solution is negative 3. Sometimes we go like this. This is called canceling. Yeah, but it really means dividing to get 1. So there are various types of canceling. This type of canceling is dividing or division to produce a coefficient of 1. I'm not going to write the 1. You all know that it's there. All righty. This is also known as the opposite. Yeah, so the opposite of x is 3. Well, then you divide and you get the opposite of 3, which is negative 3. So the solution is negative 3. Let's do one more of these, and then we'll move on to the multiplication principle. So 3x plus 45 is equal to 15. Oh, so now we have like terms, but they're on opposite sides of the equal sign. So now we're going to use the subtraction principle first. So subtracting 45, or you could say adding negative 45. That'll give you negative 30. Be very careful. You can either say you're subtracting 45, or if you prefer, you're adding negative 45. It means the same thing. And then the coefficient is 3. I sometimes like to annotate so you can see what's happening, and then that cancels off, and you get x equals negative 10. All right, so we're going to eventually put all these principles together, these properties, principles, rules. They're basically all different ways of saying the same thing. The next property is called the multiplication property. If A is equal to B, I swear this camera is driving me insane. There we go. Then A times C is equal to B times C. In other words, if you multiply both sides by the same number or the same value, then equality is preserved. Now, it's funny that I used the letter C this time, but it turns out that C will actually be a divisor. So you may use the letter D if you prefer. So you could say, and not only that, but we typically do it like this. So that's another way of saying the multiplication property. I know it looks like a coefficient, but when I do the example, you'll see that it's actually a divisor that you're getting rid of. Now, you can really take these properties with a grain of salt. They're really just to emphasize that there's an underlying principle here. In practice, you won't actually see the letters A and B. So A just means the left, B just means the right, and C is constant. So that's one of the reasons why we use the letter C for constant. But it is, in this case, going to be a divisor. So let me give you an example of that. So this is your C. So if you prefer, you want to call it D, you certainly can. Divisor. Okay. I'm just calling it C for constant. What's A? A is the whole left-hand side. That's A. And B is the whole right-hand side. And so this is C. So we're multiplying A times C and then B times C when C is equal to 4. So there's that C that I was talking about in the principle or the property. Make sure you multiply in the numerator. You don't want to go like this, because if you go like that, you're going to get 4 times 4, and it's going to be 16. You don't want to do that. So multiply in the numerator. All right. So this becomes 4x over 4 And probably in the next example, I'll just multiply to the left, and then you don't have to worry about switching the order. It'll already be in the right order. And then this becomes -8. And then 4 divided by 4 is 1. And as usual, we omit the 1, so the solution is just -8. Okay. So that's the multiplication property. Sometimes the variable is not x. Sometimes the variable is not x. In this case, the variable is t. Here's your constant, -5. This time I'm just going to go ahead and multiply on the left-hand side. If you prefer, you can use parentheses on both sides if it makes it a little bit safer. So for the left, I multiply on the left. For the right, I multiply on the right. And that leaves my equal sign clean, so I don't have a bunch of mess right here. Typically, we just cross these guys off. -5 divided by -5 is 1. -3 times -5 is 15, and we omit the 1. So t is equal to 15. Why don't we try to squeeze one more down here before we move on. This time you're solving for p. So p is your variable. What's cool about a negative variable is that you can use either the multiplication principle or the division principle. It doesn't matter which. All right, it's up to you. Since I'm now talking about the multiplication principle, let's go ahead and do that. We're going to multiply both sides by -1. I'm really being extra careful here. I'm using a dot and I'm using parentheses. That's like having double insurance or double coverage. You really don't need the dots, but since I'm talking about multiplication, I really want to emphasize it. So I have a -1 times a -p. That's just going to be p. And then I have a +40 times -1, which is -40. Okay. Wow. This lesson is a lot shorter than I thought it would be. I guess it's good. Well, we haven't done the word problems yet. Let's do a couple more of these before we do the word problems. Just make sure we really have exposure to all the different possibilities. Okay, so now we're going to put all of this together. Okay, all the different techniques, we want to put them together. So use everything that you know now. We're at the very end of chapter 3. So first thing you notice is that you have r's on both sides of the equation. That's not good, right? You want all your r's to be on the same side of the equation. It really doesn't matter which. Okay? So you have choices. It's your choice. All right, it's up to you. If you want to move your variables to the left, you go like this. Minus 14r, minus 14r. Make sure you put a 0 on this side. If everybody's gone, put a 0. And then you're going to add the two negatives. So that's going to be negative 21r. Make sure that you add them. I mean, you're technically subtracting them, but really in your mind, it's 7 plus 14 when you're actually doing the math. Okay. And then now you're going to use the division property. You're going to divide both sides by negative 21. Don't panic. It's all organic. 0 divided by any number other than 0. So 0, you will never have 0 divided by 0, not in this class. But 0 divided by negative 21 is just 0. Don't panic. Okay. I often see my students just kind of freak out because they remember some rules about 0 and they're not quite sure, what it is, So it's like you have nothing and then you're sharing it or dividing it by negative 21. Choice number 2 would be to move the 7r onto the right-hand side. Put the 0 on the left, and then the right-hand side just becomes 21, and you're still going to get the same result. So either way, tomato, tomato, they mean exactly the same thing. Not so bad. Example 14. Solve for y.
Mars.
All right, solve for y. So I want to move all my variables onto the same side, and it really doesn't matter which. This time I'm not going to do the two choices, although you do have two choices. You always have those two choices. I don't always show you both choices. I'll let you decide if you want to see the other choice. If you want to try it, just try it the other way. So I just go with whatever seems easier to me. It seems easier to me to move the 8y onto the right-hand side. Make sure you move the y with it. I often see people do that, and I know what you mean, right? I mean, if I were walking around the classroom looking at your work, I mean, you probably would get the right answer, but it's just bad form, all right? Don't be lazy. Laziness is not the friend of mathematics. Not until you get really, really good at it. 60, bring it down. 4 plus 8 is 12y. Well, there's no negatives this time. Divide by 12, and you get y is 5. Okay. I guess one more, and then we'll have to start doing the word problems. Go back to x. Just between you and me, you can just always use the letter x. The only exception to that is if the problem specifically, instructs you to use a particular letter. Well, then, because we're using a machine, a computer, you have to do what the computer says. But I mean, in reality, just between you and I, when you're solving an equation, you could just always use the variable x. Make sure I write it down correctly. We're getting towards the end here. All right, so x plus 20 equals 17 plus 4x. I need to get all my x's onto one side and all my variables onto the other. It really doesn't matter which way you go. So if you just like to always do it the same way, here's my suggestion. I recommend move your x's to the left and do that right away. As soon as you see an equation, any x's that are on the right-hand side, move them over to the left-hand side. You're using the addition or the subtraction principle. They're basically the same principle. That's where you add or subtract the opposite. So when you're using the plus and minus, it's opposite. All right, remember there's an invisible 1 here. So you've got 1x minus 4x, that's negative 3x. Okay. If there was nothing left over here, I would put 0, but I still have a 17, so I'm not putting 0 yet. And now I'm going to subtract 20. Yeah, the opposite of positive 20 is negative 20. So I got 17 minus 20 is negative 3. Okay. And finally, I'm going to try to get rid of the negative 3. Divide by negative 3. And I'm going to get x equals negative divided by a negative is a positive 1. There you go, folks. Though that is 15 examples. Basically, I tried to cover every possible outcome, everything that you would see, and so that you get the techniques of solving equations. All of your answers should be integers. Yeah, if you get an answer that's not an integer, you probably made a mistake. An integer could be positive, it could be negative, or it could be 0. Those are all considered integers. Okay, no fractions until we get to the next chapter. All right, well, I like to end this lesson with some word problems to give you your daily dose of word problems, keep you strong, keep you healthy. Well, let's start off with some simple translations. Let's go ahead and use x for the unknown number. So let x be the unknown value. So this is what I mean. You must use x now, okay? Because I'm telling you. If I would have said let p be the unknown, then you have to use p. If I say let n be the unknown, then you have to use n. So this is what I mean by you must use the variable that I told you to use. Most of the time it's x. Five more than a number is negative 4. So first translate. All right, into an equation. So what's that equation going to be? 5 more than a number is negative 4. And since this is addition, you can change the order if you like. So I would accept either one of these because it's addition. All right? That's only going to be true for addition. I guess it's also true for multiplication as well, right? Because if something is true for addition, it's also true for multiplication. But in this lesson, we're talking about more than or something like that, addition. All right, I could say increased by. I could say the sum of. Any of those phrases that we've seen in the past, they still stand, you know, all the different ways of saying plus. All right, I'm just going to do one of these. I think that's enough. Yeah. Let's try another one. I said I was going to do one of these, and now I'm going to do another one. Well, it'll be slightly different. All right, 8 less than twice a number is 20. Now, I said this before, and I'm going to say it again. Less than means subtract, but you must reverse the order. All right, and I know I said this before, but you got to put it in the right order. So reverse the order. Twice a number means multiply by 2, and then do 8 less than. Okay. Do not write it like this. That's the way it looks if you're just reading it. 8 less than twice a number, and your brain says 8 minus 2x. Some of you fell for that on the last one. Don't fall for it again. All right, you're going to get another chance at this. So this is incorrect. Do not do it that way. With subtraction, there is only one correct answer. You do not have a choice with subtraction. With addition, you do. Right? Addition is liberal. It gives you choices. Right? Subtraction is not very forgiving. It's just do it this way, and there is no other way around it. All right. Is equals 20. Okay, so there is only one correct equation for this example. Okay, and now we're going to solve it. Just like we solved all the other ones, we're going to add addition principle first. So you're going to get 2x, bring it down the 2x. I like to scoot it over. Bring down the equal sign. 20 plus 8 is 28. There's no negatives here, so just divide by 2, and you get x equals 14. Wow, that's like the most popular answer we've had today is 4. It seems like 14 has come up quite a bit today. So. Okay. One more. We made it. We're done with chapter 3. Hooray! We'll probably do another chapter before we have, so we'll have quiz. You'll have some quizzes on chapter 3, but I'm not going to mention a test, an actual examination anytime soon, but there's definitely going to be a quiz on all of this. I guess our last example is we're starting to get into the actual word problems, like the type that involve lots of different values and such. All right, so suppose you hired a plumber to fix a broken pipe in your house. Plumbers are expensive. On the bill, you were charged a total $775. $255 was listed as parts. And the rest was labor. If the hourly rate for a plumber is $65 an hour, how many hours were needed to complete the job. The problem takes up longer than the actual solution will. So, all right, so two parts to this problem. First part is to find the equation, and the second part is going to be to find the solution. In other words, the number of hours. All right, let's do the equation first. All right, so we've got the total. That's going to be your equal to. So you already know the right-hand side of your equation is going to be equals 775. That's the total. The total is, yeah, I like to cross off the word of because is, so the total charge is, that means the same thing in English as of. Yeah. Next, we're going to talk about parts. They charged you for parts. That means the parts did not have a variable. So there's no variable associated with parts. Okay. Look for the word rate. Rate is a variable. Think about it. If you work for 1 hour, well then X is 1. If you work for 2 hours, then X is 2. So the rate is telling you how often you're being charged the $65. $65, if I really wanted to be careful, I would say per hour. Yeah. / hour, you could say per hour. I already said it right here, the hourly rate. So this is implied that that's $65 per hour. All right, I'm going to use X for hours. So it's going to be plus 65X. And there's your equation. Now again, this is addition. So if you write addition in the reverse order, it's still correct. Okay. And then now you're going to solve this. These numbers are getting kind of large here, so I'm going to erase some of this work to solve this equation. I don't think I can solve it in this tiny little space here. Normally, I write it like this, 65x plus 255. Whenever it's addition, I like to exercise my freedom, exercise my choice, and just go ahead and put the X in the front. That's the standard order. Although I would still mark it correct if you wrote it in the way that I have it here. Okay, they're the same. One of them's traditional, you know, the other one's just non-traditional, I guess. Okay, and so now we're going to use the principles that we learned. Negative 255 on both sides. I like to scoot over my 65x, bring down the equal sign. That'll be 520. And then I'm going to divide both sides by 65. That's a little bit much for my brain, so let's go ahead and do it this way. And I've been doing this job for 20 years. I've been doing math for, 49 years. I mean, since I was a little baby. And I still can't do numbers past, I don't know, I can do up to about 200 in my head without writing anything down. But once it gets into the 500s, into the thousands, I'm just like any other human being. It's like, I don't know, I got a cell phone. I can do it on my cell phone if I really want. Let's see, 65 goes into 520. I'm going to guess 8 times. And really, I'm just guessing. 8 times 5 is 40, carry the 4. It was a good guess. 8 times 6 is 48, plus 4 is 52. Good guess. So the answer is 8 hours. I know I've mentioned this before. At the very end of the semester, it'll probably be one of the very last things we do before the final exam. We're going to talk about hours, minutes, seconds, days, weeks, years. When we get to that, I will be very picky about the hours. Is this hours? I'll ask you questions where I'll have you, change it from hours into minutes, and I'll make sure that you have it in the right form. That day is not today. The answer is essentially 8. Don't really worry about I hope you know that it's hours. I hope you've read the question and understand that we're charging you by the hour. But, there's going to be questions where, suppose it's a rental car. They don't charge by the hour. They charge by the day. They also sometimes charge by the mile, too, depending on what kind of plan you got. Cell phones. I remember back in the 90s when cell phones first came out, they charged you by the minute. Can you believe that? You're on the phone every minute. You're getting charged, Oh, they used to have this thing, call after 9 or something, or on the weekends, and you got a deal. But you guys are all, I don't know, some of you probably remember that. Anybody remember the 90s out there? I know some of you do. All right. Well, I hope we meet again someday. Until then, this is Dr. J. I will see you on the internet.